and welcome to episode number 14 of the weekly Google Cloud Platform podcast. I am Francesc and Mark, and I'm here with my very, very illustrious colleague, Mark Mandel. Hey, Mark. How are you doing?
I'm good, thanks. How are you doing, Francesc?
Pretty great. Very excited about today. We're going to be having our first episode ever about storage.
Storage is a very exciting topic.
And very, very vast. There's a lot of things to talk about storage.
It's true. I think, it's one of those things that everyone kind of has to do it, but may not necessarily think about it all that much.
Yep. We're going to have our colleague, Paul Newson, specialized in storage. And he's going to be telling us everything we want to know about it. So very excited about that.
Yep.
But before that, cool thing of the week.
Cool thing of the week. I particularly like this one as it plays with Kubernetes, and I like Kubernetes a lot. One of our fellow Googlers, John Wayne Parrott, he wrote an article recently called Building a PaaS on Kubernetes, or Opinionated Deployment Tools in Kubernetes. He built sort of he calls it a proof of concept. Actually looks really interesting. Platform as a service solution called Knoll on top of Kubernetes, and sort of looking at how you can explore Kubernetes to build some more interesting things. It's pretty cool. It sort of sits in that sort of Heroku-ish space where, you can do a git push and it'll build things and then put it up on Kubernetes for you. It's quite cool indeed. He has a really nice demo that shows it sort of in action where he does a git push and then it sort of builds a Docker file and then sort of takes that live and builds a new version of it, kind of in that sort of app engine-y type way as well. It's really kind of a nice mixture of different paradigms, and it sort of explores how you can say, okay, cool, we have this great infrastructure of Kubernetes. What can we lay on top of that, to make things either better for my particular use case, or just better overall, maybe.
Yeah, no, I really like it. I went through the article. The two things that I prefer the most, by the way. One of them was the demo itself, which is built on AskKinema.
Yeah, I'd never seen that before. I really like that.
I had never seen that before. For people listening, it's basically looks like a video, but it's actually it looks like a screenshot of a terminal, but you can actually select the text.
Yeah, yeah, you can see it. Like if you want to copy the commands the person used. It's
so
awesome.
that's pretty amazing. And also what I like is the first phrase of the whole post, which is, you should be building on top of Kubernetes. Seriously. I really like it.
A sentiment I can definitely get behind.
Yeah, I was like, after that, okay, I'm sold. This is a good article. No, but seriously, it's a very, very good article. And I think it's very interesting, especially because even like if you want to build or not on top of Noel, or I don't know. I actually don't know how to pronounce it.
I call it Noel.
I'm going to call it Noel because
okay.
It's like kind of French for Christmas,
Okay.
Happy. Either if you want to use it or not, I think it's quite interesting to see how you can build higher abstractions on top of Kubernetes. How all of these simple concepts of pods and services and replica controllers, they all match together to allow you to build really, really cool stuff, really.
Yep.
So we'll definitely have the link to that blog post on our show notes as always.
Wonderful. So why don't we have a chat with our friend Paul?
Let's go for that.
Let's do it. We are joined today by yet another of our most excellent of colleagues. A gentleman by the name of Paul Newson is joining us today to talk us about storage in the cloud. Paul, how are you doing today?
I'm doing well. Thanks, Mark.
Thank you so much for joining us.
It's my pleasure.
So if people don't know who you are, which I hazard a guess is simply not possible, do you want to give us a little bit about yourself and your background and sort of what you do at Google and that sort of fun stuff?
Sure. So I'm a developer advocate at Google, as you just mentioned, which means I get to do fun things like this with my time. Developer advocate's one of the titles that we give software engineers who work in developer relations. So we get to come out to conferences and talk to customers and give presentations and basically make people aware of the awesome stuff we have in the Google Cloud Platform, and hopefully inspire them to use it, teach them how to use it. And so I'm very excited to be here today. Before I was a developer advocate for the Cloud Platform, I had the privilege of working on the Cloud Platform for about 3 years. I was a software engineer on the cloud storage team, which is how I have become known as the developer advocate, who seems to know something about storage and why you've asked me to come here and talk about it today.
Nice. And yeah, actually, that's the whole point of the episode. We want to know more about storage. And this is our first episode where we're going to cover storage specifically. And there's so many options that we don't want to make it like a deep dive on every single option because the podcast is half an hour, not half a day. So we're going to have to concentrate on, okay, I have some data. I want to store it. What do I do?
Yeah, so I'm gonna try to kind of give you a roadmap or a decision tree about, I have this stuff and it kind of looks like this. So what's the best fit for me?
Nice.
And
Awesome.
and there's sort of a couple of nodes on that decision tree. First, let's talk about your data, which is, is it structured or is it unstructured? If it kind of looks like a table, it has rows and columns. Roughly speaking, you're looking at structured data, and we have a number of options for that. If it's just a big bag of bytes, and you're sort of handing it to us and saying, here's a big bag of bytes, please store this for me, I'm going to ask for it later, that's unstructured storage. So, to a first approximation, you can think of the unstructured storage like images, videos, zip files. There's probably internal structure to these objects, but as far as the storage services are concerned, it's just a bag of bytes, and we're just going to faithfully reproduce these bytes in the same order you gave them to us and hand them back to you. So in terms of and then kind of the other dimension, which we can sort of look at the different options you have are fully managed, no ops, cloud native storage services versus I want to run my existing storage infrastructure, which I'm running on my own servers. I just want to run that in the cloud. So we kind of have the lift and shift versus the cloud native approach. So if we're talking about cloud native unstructured storage, that's kind of the simplest conversation to have. If you are a developer, which if you're listening to this podcast, I'm assuming is the case, you're most likely going to use Google Cloud Storage for that, because that's the one where your application is in control of the data. There's a conversation to be had about Google Drive and where that fits into this, and so if your application, you're adding something that kind of looks like a new app in alongside other apps that are being used, and you want to interact with data that's stored in spreadsheets and docs or maybe your own file format, but it kind of looks and feels a lot like docs or sheets does. There may be a place for Google Drive in that scenario. But I'm going to assume for the rest of this conversation that, it's that Google Cloud Storage is going to be your unstructured option there. And that's in terms of the fully managed, fully hosted, no ops. You just store the stuff, and it's our problem how to serve it up when you ask for it later. If you're looking for more of a lift and shift solution, you can easily run whatever your existing solution is on our VMs. And we have persistent disk in a variety of flavors that can be used to store that. There's a lot more ops overhead to doing that, right? Because you need to be aware of, how is my data replicated across multiple VMs so I don't have a single point of failure if I'm using something like local SSD. If you are using a persistent disk, then you're not going to necessarily lose the data if there's a problem with a particular VM, but you may have an interruption to being able to serve that data while you bring a new VM up to attach to that persistent disk. So that's kind of your options for unstructured data.
So I have a quick question about structured versus unstructured. The way you described it was kind of like if it has columns, it is structured, and if it's just a bag of bytes, then it's not structured. What about a bag of JSONs?
That's an interesting question. So it kind of depends how you're going to use it, and how you want to be able to look up those JSONs. Okay. So if I kind of view JSON as an interchange format in that, for example, when you send a row of information to BigQuery to load it into BigQuery, you give it to BigQuery in JSON format. Mm-hmm. So you could arguably say that BigQuery is storing, a whole bunch of JSON data because that's how you gave it to BigQuery. But really, it's not. That was just the interchange format that you used to hand the data to BigQuery so it could figure out, which pieces of data fit into which columns. There are databases which are kind of native JSON databases. I'm not super familiar with them, so I'm not going to talk about them and say something incorrect. But if you are super familiar with one of those and you understand how to run it in a high availability way, again, you can run those types of solutions on compute engine VMs, and you have all the advantages of running in the cloud. But there's a lot more ops overhead on you because you're the one who's setting up that software. You're making sure that you have the right OS patches, and so on and so on and so on.
Cool.
So did that actually address the question you were asking?
Yeah, absolutely. So then we've covered a little bit where to store it when the data is not structured. So you just, as you said, I really like that expression, the bag of bytes. What if I have something more structured?
All right. So if you have something more structured, we have a few options for that. I'm going to say that with no other information at my disposal except that you're saying, I've got some structured data and I'm building an app, the go-to answer is going to be Cloud Data Store. Cloud Data Store is a structured NoSQL database. It scales gracefully in terms of both performance and cost from 0 bytes up to terabytes. And it has a very flexible schema. You don't have to define your schema up front. This Cloud Data Store is available as its own standalone service, but it was born as the data store solution for App Engine. So it's really, really well optimized for these serving scenarios where you have relatively small pieces of data that you want to look up by keys, and there's structure within that data in that you have individual properties within each of these rows. It gives you some limited querying functionality, and it also has some support for cross-row transactions, which can be very important for certain applications. So with no additional information, I'd say go with Cloud Data Store. It's probably the answer you want. But the other thing I would, put up for your consideration is if you're working in a context where you have very deep knowledge of relational databases and you want a relational database solution because that's what you know how to program, that's what your staff knows how to program, or you want to take advantage of some of those features like relational integrity and a very structured data model, then you should also look into Cloud SQL, which is a fully hosted MySQL solution. The Cloud SQL solution, there are now 2 generations of it. I would encourage you to look into the second generation. It's not generally available at the time we are having this interview, but you should go to our website and see if it's generally available now. It's certainly available for you. It's in beta right now. You can go play with it, and it is very scalable. It can handle a lot of scenarios. For most applications, it's probably going to be sufficiently scalable. It's only if you are expecting a runaway success and you're going to need to scale into the terabytes of data that you may find that it doesn't scale, high enough for your needs. So that's kind of the SQL versus NoSQL node of the tree. If you are, heavily into relational databases, you love relational databases, we have a hosted service where we handle the operations, and that would be Cloud SQL. If you are far more comfortable with the NoSQL way of doing things, then Cloud Data Store would be your choice. So those are kind of the 2 go-to solutions. But there's a third structured solution I should talk about, which is Cloud Bigtable. Cloud Bigtable is kind of a lower level NoSQL solution. It is also a NoSQL solution, but we're talking about really heavy machinery. The guidance we give is that if you're storing less than a few terabytes of data, Cloud Data Store is probably the way to go. In terms of when to consider moving to Cloud Bigtable, we recommend sort of an approximate 1 terabyte minimum of data before Cloud Bigtable is going to be a cost-effective way to start storing your data. The other hurdle to consider with Cloud Bigtable is that you are using a lower level API, whereas with Cloud Data Store you have a SQL-like language that you can use if that's something you're familiar with. It also has some higher level libraries which you can use to access it, like the NDB library that's available as part of App Engine. With Cloud Bigtable, you're using the HBase API, which if you're familiar with it is great. And if you already have a bunch of existing code which uses it, then this is exactly what you should be looking into. However, it is a lower level API. It basically gives you sort of put, get, scan semantics, not higher. There's no cross-row transactions. There's no sort of query language or anything like that. It's very much a low level put, get, scan sort of API.
Is there like particular applications or particular types of data that would be like very like that are usually used in something like Bigtable? Like there's a particular use case, that's the word I'm looking for, a particular use case that this would be pertinent for?
Well, the other characteristic that Bigtable has, which is really, really nice for some scenarios, is extremely low latency. Single-digit millisecond latency in the 99th percentile for reads and writes, which is pretty amazing. The other thing that Bigtable gives you the opportunity to do is mix your what I'd call your serving workloads with your analytics workloads on one database, which is often very difficult to do. This is why people have data warehouses, right? You have your operational database, which is kind of your serving database, the one that is that your web, your mobile app or your website is hitting and getting the most up-to-date data. And then you sort of replicate that into another analytics system, which has a slightly older view of the data. And then you run your analytics on that. With Cloud Bigtable, the latency is low enough you can use it as as a fantastic operational database. You can also, for example, just run a MapReduce or a data flow directly against your Bigtable. And if you provision your Bigtable with enough resources, it can handle both the analytics workload and the serving workload simultaneously. So if you have a scenario that looks like that, Bigtable is definitely worth looking into.
Very nice. So we've seen structured versus unstructured. So for unstructured, we said that cloud storage could be probably the best solution in general, like the go-to solution. For structured, depending on how much you structure it, so you may go with SQL or NoSQL. Mm-hmm. And for NoSQL, we said that if you really want the real thing and you have a huge amount of data and you want amazing performance, then you should consider Bigtable. But otherwise, data storage should be the go-to solution for most of the cases.
Yep, and that's all true.
Cool. So what about when you want to run something slightly different? Like you're saying, yeah, okay, so if you have non-SQL, you should go with data store. What if I'm already running MongoDB or stuff like that? What good people should do for those?
Yeah, again, you can just lift and shift those into the cloud. We've got these great VMs. You can choose the VM size that you want. You can cluster it in whatever way you want that your favorite package, allows you to do. You can choose to run it on the hard drive backed persistent disk, the SSD backed persistent disk, or local SSD, depending on how much performance you want and whether the software package you're using gives you, the resilience to failures. But again, now you're not talking about a cloud native, no ops, fully managed solution at that point. Like there's a lot more responsibility on you to understand what's going on. It's just like running it on your own machines. It happens to be running on our machines instead.
We've talked in the past kind of like compute as a continuum. This is pretty much storage as a continuum.
Yeah, basically.
Do you want us to run everything for you and manage all that stuff for you? Or do you want to just, create your own persistent disks and worry about like what the IOPS are on this particular SSD?
Right. So there's one other structured storage solution we have, which is definitely worth talking about, and that's BigQuery. a lot of people will approach our platform and they'll look in the storage selection in the storage section in our console, and they won't see BigQuery there because it's hiding under big data, where it should be, because it's a really great analytics tool. Like that is its natural home. So a lot of people won't think about using it as a storage medium, but it's actually a fantastic way to store your data. It costs you the same per byte to store, archival data in BigQuery that it would cost you to store it in cloud storage, durable reduced availability class of storage, for example. The price of those two things, those two types of storage, is the same per byte. But by storing it in BigQuery, you can run a SQL query against it, and you can run massive SQL queries against it. And talking about the continuum of computing, the continuum of storage here, you don't need to tell us when you run a BigQuery query, oh, by the way, I'd like you to dedicate, 10 32 core servers to this query, please, and I need this much throughput. You just give us your query, you give us your data, then you give us your query, and we give you the answer as fast as we can. And we have these very large clusters that are already provisioned, which are this sort of massive shared tenant solution, so that, when I'm running my query, I get to chew up a huge portion of those resources, and then my query's done. In the next 10 seconds, someone else's query is taking up those resources. So you get these sub-minute, slices of time on these huge analytics clusters to answer just the question you're asking it. It's really quite an impressive model, and I encourage you to, particularly for data that is not on your serving path, data that you're going to primarily use to gain insights from, put it in BigQuery and keep it there. And then you can always do these ad hoc queries against it in the SQL language that you and your analysts probably already know and are very proficient with. Now, somebody might say, but wait, I need to run a data flow against it because I'm doing something like building a machine learning model, for example, which I can't do. I've got to run my own custom code, and I can't do that in SQL. And there are some features of BigQuery where you can plug code in, but it is far more structured than what you could do in something like Dataflow. So in that scenario, that's okay. You can still read all of your information out of BigQuery in your Dataflow job or your MapReduce job if you're using Dataproc with our connectors. So you're not limited to only using SQL for your analysis. So there's really no reason to not store your long-term archival analytics data in BigQuery. That's where you should be using it for your data warehouse.
Nice. So I think that now I almost understand all our options that we have for cloud storage. So just to go over all of them quite quick, we made the distinction between what we're saying is pretty much managed and cloud native. And we still have a bunch of other possibilities, which is like you build it on top of VMs and you install whatever you feel like it. But for the ones that we propose as cloud natives, we have cloud storage for unstructured, and then Cloud SQL for SQL, Data Store for NoSQL, and Bigtable for NoSQL that runs incredibly fast.
And it's huge.
And then we also have BigQuery, which I really had not think about a storage solution. But I can definitely see it. I really like it.
It's interesting, actually. You could almost say that BigQuery sits in a weird space between like SQL and NoSQL, because you can do fun stuff like query JSON out of it.
Yeah.
And but still have a schema at the same time if you wanted to.
BigQuery is kind of an amazing product, actually. It's in the middle of many, many, many cool tools that we have at Google. Cool. So is there anything else that you would like to mention before we finish with this interview?
Gee, that's a fine question. Let's see. Well, we've touched on the big managed services. I guess the one thing I'd like to leave is there is definitely a place for lifting and shifting existing applications into the cloud as a way to get a win out of using the public cloud without having to do a lot of redevelopment. So I certainly don't want to discourage people from doing that. However, if you're writing something new, I highly, highly, highly encourage you, even if it's not what you're currently familiar with, to instead of doing a lift and shift where you're running your own thing on your own VMs and you're taking on all that operational burden, I highly encourage you to see, can I build my application on these cloud native, fully managed, no ops solutions? Because they will allow you to scale very, very high, very, very easily without hiring an equal number of humans to the amount you scale to manage the operations of these things. So if you are approaching the cloud and doing something new, I highly encourage you to preferentially investigate the fully managed no ops solutions we have to offer.
Yeah, I definitely agree with that, especially not only for storage, but also for computing, as we were talking. Like, if you're able to run your code on App Engine, it will pay off very, very soon because you don't need to manage absolutely anything.
Yep.
So yeah, that's a great piece of advice, I think.
Definitely. Well, thank you very much for joining us, Paul. We really appreciate you taking the time.
It's been my pleasure. Thanks a lot for having me on the show.
Thank you, and I'm sure that we will have more storage-related episodes in the podcast soon. So see you soon.
All right. Thanks a lot, guys.
Cheers.
Bye. So thank you very much, Paul, for this amazing interview. I learned a lot.
Yeah,
and
definitely.
Yeah, actually, I know that this is the first episode of a series of episodes where Paul's going to be here explaining a bunch of stuff about storage. Because there's a lot of things that are really useful. And at the end of the day, everything we do is you process data and then you store it somewhere.
Yeah.
So yeah, very important topic. Okay, so let's go for our third section of the episode, the question of the week.
Yeah.
So I think that you got a pretty good one today.
I think so. It's probably a topic that some people have definitely heard around the traps. The topic was brought up directly to me by a gentleman by the name of Jeff Schnitzer. Started talking about using Java 8 in standard App Engine. It's a long discussed topic of monumental proportions. But what sort of options do you have if you want to start using Java 8 on App Engine?
Okay, so the quick answer is Java 8 on App Engine doesn't work yet.
Yeah.
On classic App Engine, what we call normal App Engine. But if you want to, you can use it directly on managed VMs.
Yes.
So it's something that works really well, and you can get all the nice things of Java 8.
Definitely.
Now, the thing is that we're actually working on having Java 8 supported on standard App Engine. But App Engine is a pretty complex product, has a different runtime. We change a little, we make it so it's very safe and scales very well. So, that takes engineering effort.
It's not an easy process by any stretch of the imagination.
But we're definitely working on it. We know that people want it. And I mean, we're developer advocates, so we're definitely pushing.
We appreciate it as well. Yes.
We're also pushing internally to make sure that this happens. And it will happen. When? Well, we cannot really say a date, but sometime soon. I hope very, very soon, but who knows. But in the meanwhile, I've also heard that there's actually some way of getting the feel like you're using Java 8 without actually having it.
Yeah, so obviously standard App Engine, you're limited to Java 7, but there's a great project out there called Retro Lambda. So while you don't get the full features of everything that comes in Java 8, if you want to use the Lambda expressions, but still have it fall back to Java 7, you can totally do that with an App Engine. We promote this probably a lot more within Android because of the Java 7 requirements there, but no, you can totally use it on App Engine. It's going to make your syntax a whole lot nicer, especially if you've started playing with Lambdas a lot more in Java. And it'll work down to Java 7. So if you haven't played with it within your GAE standard applications with Java, I reckon give it a fun go. I think it'll be a really pleasant experience.
And if you really want to have actual lambdas, which are real lambdas and closures and things like that, you can also just migrate to Go. Nah, just kidding.
Not that you're biased in any way, shape, or form.
Yeah. We'll have a link to the GitHub repo for Retro Lambda on the show notes, so
Definitely.
you can have a look at it. Great. So before we finish, as usual, where will you be next time we'll speak together?
We'll be coming up in a couple of weeks, I think it is. Yeah, it is a couple of weeks. Launch Hackathon on the 26th of February. I will be there. I will be at GDC. That is ramping up. We're going to have a great Google booth. Super excited about that.
Yeah, it's going to be fun.
Definitely come by. We're going to have Cloud Spin. We're going to have all sorts of fun stuff happening at that event. So that's going to be awesome. And then after that, I will be at Strata.
Nice.
How about yourself?
So by the time this podcast comes out, I will be flying across the ocean coming back from Dubai. There's GopherCon Dubai that will happen yesterday when this podcast comes out.
Nice.
So yeah, on February 23rd, there is the GopherCon in Dubai. And after that, it's going to be quite a busy month with South by Southwest, GDC here in San Francisco, and there's also DroidCon in San Francisco. So, and all of those things, of course, same week.
Yeah. Oh yeah, I'll be at GCP next too. This is how much stuff's on. I completely
and
forgot.
GCP next. Yeah. So yeah, it's gonna be a fun month in March. Yeah. Looking forward to April.
Yes, very much looking forward to April. My birthday's in March too. I'd completely forgotten that. Wonderful. Well, thank you very much for joining us yet again, Francesc.
Thank you very much. And as usual, if you have any questions, any suggestions, any comments, feel free to contact us. I don't think we need to do it today. Do we need to do it today?
I think we're okay today.
I think we're okay. Let's do it next week.
We'll do it next week. Wonderful.
But yeah, contact us. We're very happy to hear from all of you.
Definitely.
And as usual, thank you so much for being here with me today, Mark.
Yeah, thank you, Francesc.
And talk to you next week.
See you next week.